In this video, I will present to you the identity for the cosine of the sum and difference of two angles. But more than that, I will show to you the proof for this set of identities. Cosine, sum, and difference identities. The cosine of alpha plus beta is equal to this, cosine of alpha times cosine of beta, minus sine of alpha times sine of beta, and the cosine of alpha minus beta is equal to this. So that's why you call it sum and difference identities for cosine. What you are looking for here is the cosine of the sum of two angles and the cosine of the difference of two angles. So when I was a student in college, this was quite a big chunk of knowledge to remember. And so we had our own mnemonics to help us with remembering this identity. Okay, so I will present to you a proof for these identities. And in fact, that is the main concern of this video. The proof will go this way. We will begin by constructing isosceles triangles that is inscribed in our unit circle. And we will take advantage of our rectangular coordinate system to produce the coordinates for the vertices of your triangles. And then after that, we will show that these isosceles triangles are congruent. And because they are congruent, their corresponding parts, their corresponding sides are also congruent. And in particular, side CA, okay, is congruent to side BE. And from that congruence, we shall derive your identities for the sum and difference of angles for cosine. Let us begin by labeling our vertices. So point A is just 1, 0. We will trace an arc whose length in radian measure is alpha. Okay, and so point B is going to have a set of coordinates. It's cosine of alpha and sine of alpha. So that one is a direct result of how we defined our circular functions. Now from point B, we will extend it by beta to produce a longer arc, alpha plus beta. And so that one would have a set of coordinates, and it is this, cosine of alpha plus beta and sine of alpha plus beta. Now down here, we will trace another angle, clockwise, okay, also whose magnitude is also beta, but clockwise. The coordinates for point E is this one, cosine of negative beta and sine of negative beta. Okay, so we now have our two isosceles. These are two isosceles triangles. Why so? Because their sides, this one, these are the radii of your unit circle. All of them is equal to 1 in length. Now, their included angles are also congruent. Okay, look at that. A or alpha plus beta, okay. Now, this one is alpha and this one is negative beta. But as an angle of a triangle, we don't call it negative beta. We call it also beta. So, this included angle is also alpha plus beta. So, by the triangle congruence, which we call SAS, side angle side, the two isosceles triangles are congruent. If they are congruent, then their corresponding sides are also congruent. And so side CA is going to be equal in length to side BE. They are equal. Let us obtain the length of side CA using distance formula. Okay, why distance formula? Because we are given a set of coordinates for the endpoint of your line segment, okay? Okay, so this is a pair of coordinates for point C, another pair of coordinates for point A. So using your distance formula, it's just this. X sub 1, that one, minus x sub 2, and then everything squared plus y sub 1 minus y sub 2, which is just equal to 0. And then from there, we expand this using your special product, and then we simplify. Where did 2 come from? Now look at this. The square of sine of alpha plus beta plus the square of cosine of alpha plus beta, that is equal to 1. Why so? Well, from your Pythagorean identity. That's just equal to 1. Now look at this. We already have 1 here. So 1 plus 1 is 2. Okay? So that is the length of side CA. Let us now go to side BE. Again, using your distance formula given the coordinates of the endpoints of your line. Let us simplify this. Now pay attention to this. This is an even function, and we have an even identity for that. Cosine of negative beta is just equal to cosine of beta. So we can just replace this by cosine of beta. And this one, the sine function is an odd function. Sine of negative beta is equal to negative sine of beta. And you know what's going to happen with minus negative. It's going to be positive. We will expand these expressions using your special product. And again, we will simplify it. So where did 2 come from? Look at this. The square of sine of beta plus the square of cosine of beta, that's equal to 1. The square of sine of alpha plus the square of cosine of alpha, that's again equal to 1. 1 plus 1 is 2. Now look at this. Negative 2. This is positive 2. So when you factor out negative 2, you know what's going to happen with that. It's going to be minus. So again, this one is just came from these two terms. We just factored out negative 2. We know now how long CA is. CA is equal to this. We also know how long BE is. It's equal to this. And they are equal. They are supposed to be equal because these two line segments are congruent. So we can equate these two measurements and we can just ignore the radical sign. We can just pay attention to the radicand, okay? So we have this next statement. Since CA is equal to BE, their lengths are equal. And by the way, these two expressions are the expressions inside your radical sign. Okay? Okay, so let us simplify this. 2 minus 2 is 0. We divide everything by negative 2. And what is the result? This is the result. Cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Now take a look at that. Isn't that the identity we are aiming to prove? So we call that the cosine sum of angles identity. Now, since we have shown that this is true, to get to the next identity, the difference of angles identity for cosine, what we will do is we will just replace this by negative beta. Okay? And so everything here will be replaced by negative beta. So it's going to be alpha plus negative beta. Okay? So cosine of alpha plus negative beta. And you know that that is equal to this. Cosine of alpha minus beta. And it's equal to this. Okay? Using your identity for the sum of angles. Now, take a look at this. Cosine of negative beta, that is an even function. Cosine of negative beta is just cosine of beta. And this one is an odd function. Sine of negative beta is equal to negative sign of beta, but it's preceded by this operation, minus. And so you know what's going to happen. Minus negative will turn the operation into positive. So this one is your identity for the difference of angles for cosine. So we are done. We have shown that given two angles, this is true.